So all these points on the circle reference some special angles. So in the first quadrant, we can see that this red dot here, the red line, which we're going to show by this red point right here, that angle is going to be 30 degrees. Okay, and so that all the red lines refer to the 30-60 triangles, and the blue line relates to the 45-degree angle here. So that's a 45-degree angle there. Okay, and that references that blue point there. And we can see that there is that 45-degree triangle that forms in there. Okay, so we want to find out all the different angles in the circle. So that one's going to be our 30-degree point. Okay, so that point's going to be 30 degrees. This point up here is going to be 60 degrees. Okay, we have our 45-degree point right in between. And we also are going to start referencing these poles, like the northwest, east, south position. So 0 degrees is going to be east, and north will be 90 degrees here. Okay, so we have 30-degree increments here. You can see the special triangles showing up. When I get to the red point here, this relates to 60 degrees, and it's symmetrical across here. So this is going to be 120 degrees at that point. And again, we are referencing these angles reference these coordinates. I'm just going to go skip to this one here. So we go 30, 30, 30. These are all in 30-degree increments, these red ones. So that's going to be 150 degrees. And this is going to be related to 45 degrees. So it's going to be 45 degrees past 90, or 45 degrees short of 180, which is going to be our west position. So that's going to be 180 degrees here. Okay, so these positions here we also should reference. Okay, and these have a position of 0, 1, 0. Okay, this is going to be 0, 1. This is going to be negative 1, 0. Okay, and as we go around the circle, this coordinate here is going to be 210. Okay, so we're measuring 210 from the 0 position. This is going to be 240, and in between it's going to be our 45-degree position, which is going to be 225 degrees here. And then this position here gives us 315. Okay, at the very bottom we have 270 degrees. Okay, which is going to be the bottom position, and that's going to be at 0, negative 1. And then we have our 30-60 positions here. This is going to be 300 degrees. Okay, and this is going to be 330 degrees at that point. Okay, there's a symmetry. The red points are symmetrical to each other. The blue points are symmetrical to each other, the same as the red are. Okay, so these are our coordinates. These are the angles, and there are coordinates that go with this depending on the circle. In this case, I've kind of referenced it as a unit circle or a radius 1 circle, and referenced the north, west, south, east points with a radius 1 circle. So let's apply this. So we have a point defined by negative 2, negative 2. So that's in quadrant 3. And it's symmetrical along x and y. So we should have an idea what that triangle is going to look like. Okay, so there's our reference triangle. And that coordinate, that point, is going to be negative 2, negative 2. Now what we also want to know is the angle that finds that same position, okay, of negative 2, negative 2. So in this case here, we don't really need to work out the hypotenuse, but we can figure out the angle theta here by just looking at the problem. We know that this is a 45-degree triangle, and that's 45 degrees in here. So this position is 225 degrees in that direction. We can also go negative 135, and that would be perfectly fine. Okay, and again, we have these coordinates reference the length, negative 2, along the x, negative 2 along the y, and then if we actually work that out, we're going to get square root 8 along the radius. So this one here, we have a point defined by root 3, negative 1. Now it's important to know root 3 and negative 1 in relation to the circle, the triangles. Okay, so this root 3, negative 1. The root 3 is a long side of the 30-60 triangle, 1 is a short side, and 2 is going to be the hypotenuse. Okay, so root 3 relates to the long side. Okay, so when I look at this, root 3, negative 1 is going to be in quadrant 4, and I'm going to draw this triangle long side horizontal, short side vertical. Okay, and that's about 30 or 30-degree triangle that we're going to find. So root 3, negative 1, that's going to be radius 2, and we want to know the exact angle for here. So we could measure this angle two ways. We can measure it in the positive direction here, which is 300 degrees, or we can measure it the same position here as negative 30 degrees, okay, because we're measuring it in the negative direction. Since we have these two sides and we're going to work out the third side, we can work out the primary trig ratio. So sine of 300 degrees is going to work out to be negative 1 over 2, short side vertical. Cosine of 300 degrees is long side horizontal, and it's in the positive direction. And then the slope, if you look at the slope of 300 degrees, it's going to be negative, and it's going to be negative 1 over root 3 slope. Okay, and again, we were able to use exact value ratios and exact value angles because we did not have to rely on the calculator here. So these ones need to be done without a calculator.